In this section, we're going to look at HTTP and once again add to our knowledge so that we can build on top of it in the practical sections. So let's take a look. HTTP, or Hypertext Transfer Protocol, is used to send data between your browser and a web server. It was developed in 1989, and the first documented version of HTTP, which was version 0.9, was a simple protocol for raw data transfer across the internet. Later on, HTTP 1.0 was formalized, which allowed messages to include headers, opening up possibilities for content negotiation, authentication, caching, and response status codes. In 1997, HTTP 1.1 was introduced, adding persistent connections and request pipelining, which really improved the performance. And then beyond that, we have HTTP 2, which was standardized in 2015 and offers even more optimizations like server push and header compression. Now, how does HTTP actually work? Well, at its core, HTTP is a request-response protocol. When you type a web address into your browser sends an HTTP request to the server, which then responds with the requested files, which are typically HTML, JavaScript, and CSS, of course. But it's not limited to these formats. HTTP now can transfer images, videos, text files, etc., etc. So here we have a typical request, and we're going to look at the different components of requests and responses before looking at creating a few requests with curl. So first up, we have the first line, which is get/http/1.1, and this is the request line. And it has three parts to it. So we have get, which is the HTTP method used, and get is typically used to request data from a specified resource, and we'll talk about other HTTP methods soon. And then we have slash, and this is the path to the resource on the server. And in this case, it's the root directory indicated by the /, but often we'll see things like /index, or we'll see /users, /profile, etc., etc. And the last part is HTTP/1.1, which indicates the HTTP version that the request is using. The second line here we have is ginandjuice.shop, and this is the host header. And this specifies the domain name of the server and sometimes the port number. And this is really important because many servers actually use what we call virtual hosting, and they will host many web applications on a single server. And so that server may have a single IP address, but then when we send requests to it, we need to know which application we want to use. And so the host header is used for this routing. Next up, we have the user agent, and this field contains information about the browser and operating systems of the client making the request. And then we have the accept header, and this specifies the type of media that the client can process. It can accept things like text/HTML, application/XHTML and XML, and application XML in this case. And the parameter on the end Q indicates the order of preference for each type, but we don't necessarily need to worry about that. Next up, we have accept encoding. So this indicates the type of compression that the client supports. So the browser in this case can handle things like gzip, deflate, and br, which is Brotli. And these are all different algorithms for compressing data. And then we have accept language, which I think is fairly self-explanatory. So in this case, our browser prefers American English. And then we have connection close at the very end. And this tells the server that the client wants to close the connection after receiving the response. And without this, the server might keep the connection open for more requests. Next up, we have cookies. And these are an essential part of browsing the internet, and they act as a way to remember state and track sessions. They have a big part to play in terms of how applications behave and a big impact on security too. So let's briefly discuss them here, and also in a later slide we'll look at how cookies are set and some different flags or parameters we can use to influence how they're handled. So cookies themselves are small pieces of data stored by a web browser that track information between multiple sessions or during a single session. We already know that HTTP is stateless, and so we need them to enable stateful sessions. Without cookies, it would be very difficult to implement things like user logins, shopping carts, and other features that require keeping track of state information across multiple page visits. When we use a web application, the server might send a set of cookies to our browser in a response. The browser then stores these cookies and sends them back to the server with subsequent requests to the same domain. This way, the server can recognize the user or the session across different requests. In our example, we have cookie and we have session equals and then a session ID. This cookie called session holds a unique session identifier for us, and the server uses this identifier to retrieve the session state for the user, such as the login status, preferences, or items in our shopping carts. Now, from a security perspective, there are a few things we need to consider. First up, cookies can contain sensitive information, so they should be protected, and we can start to do this by using things like flags. As pen testers, it's important that we know these and what they do, as when we're trying to demonstrate impact, we may have to work around some of these limitations. The secure flag ensures that a cookie is sent to the server only with an encrypted request over HTTPS. The HTTP only flag makes the cookie inaccessible to client-side scripts, and this stops it being accessed via JavaScript during cross-site scripting attacks. And the same site attribute controls whether a cookie is sent with cross-site requests, providing some protection against cross-site request forgery attacks. It's also important to consider the expiration of a cookie, and it's generally good practice to make sure that they expire after some time. Let's take a look at some simple code that sets and processes a cookie on the server side. Now, this code here is far from what you'd see on a large-scale production system, but it does demonstrate a little bit of the logic that might be happening in the back end. So first up, we have the cookie name, and we're setting this to user, and then we have a cookie value, and we're setting this to Jeremy. And then within PHP, we have access to the method setCookie, and so we're passing setCookie, and then we're passing in the cookie name, the value, and the time. And as you can see, 86,400 is 1 day in the comments, and if we multiply this value by 30, we get 30 days. In the next block, we're saying if the cookie user isn't set, then we should echo cookie named cookie name, which in this case is user, is not set. Otherwise, echo cookie name is set, and then we'll also echo the value to the screen as well. And once again, this is a really simple example, but just as a quick demonstration so that you can see how a backend application might set and process and interact with cookies. Let's also explore some HTTP methods and their general use. Something to remember though is that even though we have best practices or uses of each of these methods, it doesn't mean that they have to be used in that way. And same goes for status codes. If I'm building an application, I can set any status code I want and use any methods I want to do things. It's not necessarily a good idea, but sometimes you'll find methods doing unexpected things, and just remember that these rules aren't necessarily rules. It's a bit like the pirate code, they're more of a guideline. So the four main ones that we'll see are get, post, put, and delete. So get to get a resource, post to create a resource, put to update a resource, or delete to delete something. And there are a bunch of other methods as well, like patch, trace, head, options, and connects, and we'll see these from time to time, but only occasionally. So here we have an example of a post request and you can see that we're sending some data in the body after a blank line following the headers. Note that while it's not best practice to send data in the body of a GET request, it is possible, so once again, the rules are quite flexible here. So now that we've sent loads of data to the server, it's time to check out some responses. This is probably the most common response you'll get, and it says 200 OK. After that, we once again get some headers, and you can see that the application is also setting a cookie, and then has a body full of HTML for the browser to render for us. And the structure of the response is pretty similar to the request. But of course, we do notice some differences in terms of the response code, which we'll take a look at in a second, and the response message, and we'll also see some different headers too. And notice that we have a set cookie header as well, so it's setting a session cookie, and it gives us some expiry and some other information as well. Now, before we jump into looking at how we can use curl, we do have status codes, and generally speaking, 100 status codes are informational responses, 200 are successful responses, 300s are redirects, 400s are client errors, and 500s are server errors. And we'll probably see most of these at some point throughout the course, and it's worth keeping an eye out for them and just remembering which category is which and what that signifies. Alright, let's take a quick look at how we can use curl to create requests and view responses. So here I am in the terminal, and we can do things like, for example, I want to curl https ginandjuice.shop, and we can see that we get the response. Now, I could do something like add the verbose flag, so -v, and then come up again and take a look, and you can see that we see a load of data and a load of information about what's happening. And here you can see the GET request, so we're getting / using HTTP2, and we see the host header and the user agent and what we're accepting. And then here we can see the response as well. But this isn't a very easy way to see things. And so what we could do is, instead of doing that, is if we do --proxy, we can just do localhost 8080, and if we have Burp Suite running, whoops, we actually need to ignore certificate issues in this case, and which is with -k, certainly bring that up again. If we have Burp Suite running, this will send this through our proxy. So if we come to proxy, we can see our request and response here. Now, if we change this, so for example, I add some data, test, we actually get a response back saying method not allowed. So here in the application, we're automatically changing to a post request because curl has spotted some data, and it's updated the method for us, and we get a response saying method not allowed. But remember, I was talking about how the rules are flexible. So for example, if I do -x and I put get, we can force curl to send a GET request, but also send some data in that request. So here our original request doesn't have any data, and here we have some data in our request. And curl is quite a powerful way to script things or to test endpoints without having all of the bloated things that browser adds. So for example, you can see here that we have very few headers and we have very clean requests, and we can review the responses. So it's worth getting to grips with curl and just understanding how to send a curl request, how to send them with different methods, how to add data, how to ignore certificate warnings, and also how to proxy traffic if you need to. Alright, I will see you in the next section.